All right, guys, so we're going to start into chapter 5 today. Today's one of those sections where it's a lot of like vocab, terminology, not real hard, just a lot of stuff. Okay? So just kind of hang with me. We'll kind of trudge through that way. We're ready to go for the rest of the chapter. So chapter 4 was all quadratics, x squared, right? This chapter, you're going to have x cubed, x to the 4th, x to the 5th, x to the 6th. Like, we're dealing with all of the others. So in this chapter, like as we progress through here, we're going to look at, there's three new ways of factoring, 2.5. So 2.5. One of them, it's different, but it's not really new. So, because it's different, but it's not new, but it is. I don't know. But not really. It's like 2.5. We'll see when we get to it. All right, so we're going to learn new ways to factor. I get that. Guys, focus. So we're going to learn new ways to factor in this chapter, not today, but in this chapter. And then we're going to look at different ways of solving, because, again, we know not everything can be factored. So how do you solve things then? There's not like other formula, like quadratic formulas for quadratics. There's not other formulas like that. Okay, so we have to look at other ways. The graphing calculator becomes your best friend later in this chapter. Long division shows up in this chapter. So I'm warning you now, start refreshing your memory on how to do long division by hand. Yeah. Refresh your memories on that. Cool. Oh, yeah. You like it. It's fun. All right, here we go, guys. So section 5.1. Trey, stop speaking. Section 5.1. Again, lots of terminology in this section. So a polynomial, you've heard the term polynomial before, right? Polynomial looks like something like this, right? 4xy squared plus 3x minus 5. Each piece that's being added or subtracted together, those are called terms. They're kind of like your chunks of your problem. So how many terms does that one have? 3, right? It's got 1 piece, 2 piece, 3 piece. So it's got 3 terms. Poly means many, and nomial means terms, so it means many terms. Okay, that's what polynomial means. All right, the degree of a polynomial in one variable. So we're not dealing with like x, y, like combined x, y, z. We're not dealing with multiple variables, just x. Okay, so the degree is the highest degree of its term. So if we're looking at this one, the highest exponent is 3. So we say it has a degree of 3. Okay, what else does that 3 mean? How many answers will this have? 3 answers. It's the highest exponent. The leading coefficient. Do you guys know what a coefficient is? It's the big number. Good, the big number in front. It's coefficient. So the leading coefficient is just the big number in front. So here the highest exponent is 5. So it's a degree of 5. How many answers does it have? 5. And then the leading coefficient should be negative 8, because that's the part that's with this. Does the order this is written in bother anybody? It's not in the right order, right? 8x to the 5th. And then plus, that minus is attached here. Right, so it should be negative 8x to the 5th. This goes with this. Plus 4x cubed. Good. So that's how it should be written. So that's the next part, is talking about standard form, which most of you were like, oh, I don't like the way it's written anyway. So that's the exact same problem we just did. So standard form just wants them in the correct order, highest exponent on down. Yeah. So here we go. Fill this in on your notes. You're going to need to make sure you know this. Sorry. You can write them all by hand if you like. If you'll complain about the printed notes, I'll stop giving them to you, and you can write them all by hand. Yeah. Beggars can't be choosy, right? All right, so here we go. So there's some different examples up here. So on this first one, if I just have an example of the number 5, there's no variable with it at all, we call that a constant. There's no variable. That's just a constant. What degree is that, do you think? That's 0. Because is there an exponent or a variable? Is there an x on it? No. So that's a degree of 0. How many answers will 5 have? You can't answer that. You can't answer that. It's not, I don't have to solve it for anything. There's no variable. So how many terms is this? That's just one term. Do you know what you call something with only one term? Did you say unomial? You're kind of close. It's a monomial. I'm assuming you guys have seen that word before. Mono means one. Mano a mano, one-on-one. All right, so next example, x plus 4. All right, notice this is x to what degree? X to the first. We call something with just a plain x to the first linear. You deal a lot in Algebra 1 with linear things. The degree is 1. It is linear. How many terms does this one have? 2. It's got 2 terms. What do you call something with 2 terms? Binomial. Sure, go with that thought. All right, next one, 4x squared. X squared, this is all of chapter 4. Those are called quadratics. All right, degree is 2, x squared. How many terms is that one? That's only one term. All right, this is just one piece. It's a monomial. Next one, the highest exponent is 3, which is cubic. So that is a third degree. That will have 3 answers. How many terms is that one? That is 3. 1, 2, 3. Good. That's called a trinomial. I always think of a tricycle. It has 3 wheels. No. Third degree burns. Fourth degree burns, you're dead. Please don't. All right, x to the 4th. Guys. X to the 4th is called quartic. Quartic. Most people will forget this one more than any others. I always think of there are 4 quarters in $1, 4 quarts in a gallon. Okay, so just kind of ways to remember that the 4 is quartic. Most people want to say 4 is quadratic, but it's not. Quadratic is x squared. How many terms is this one? 2 terms. That's a binomial. All right, and then the last one up there, x to the 5th, is quintic. Quintic. Think of quintuplets. You guys heard of quintuplets? Or quincy? I don't know how thinking of quincy reminds you of 5. How tall are you? Are you even 5 foot? So we can't even say she's 5 foot. We'll say she is. Your head is not a limb. I know, I'm like, you got an extra leg or something hanging out there? I totally missed this. All right, how many terms is this one? 4. She's polynomial. There's specific for monomial, binomial, trinomial, and then anything else is just polynomial. It's like they got lazy and stopped naming them. Yep, 4 and higher. Actually, I can call any of them a polynomial, but 1, 2, and 3 terms actually has a specific name, but the rest of them don't. Monomial. All right, but guys, you do need to know this. Okay? You need to know that. No. Wrong. Call.
He said puzzle. Yeah, he said puzzle. To keep him occupied and multitask.
Quick thinking, but stop it. All right. Write each polynomial in standard form. Classify it by its degree. So is it quartic, quintic, cubic, and by the number of terms, monomial, binomial, trinomial, or polynomial. Okay? So on the very first one, 3x plus 9x squared plus 5. What order should it be written in? Good. 9x squared plus 3x plus 5, right? You want highest exponent, kind of step your way down. All right, by the degree, you would call that quadratic. Good, and it is a trinomial.
Hey, I'll tell her if I'm kidding or not.
All right, next one over there, 4x minus 6x squared plus x to the fourth plus 10x squared minus 12. Whew. What? Good. Let's start one piece at a time, right? X to the fourth. Take a look here, guys.
Minus 16x.
Try again.
Okay.
Negative 6 plus 10 is 4x squared. Yeah, if you have like terms, please put them together. Plus 4x, and then minus 12. Whew! Yeah, you ignored them. All right, so if you have like terms, put them together, okay, and then kind of put them in the right order. So by its degree, you would call that quartic, because it's x to the fourth. Quartic. That's good. That is a polynomial. There are how many terms? There's 4. We just call that a polynomial. Good. Yeah. On the we'll have a quiz after the second section. I'll be honest with you, on the quiz, if you just wrote like for the degree you wrote like fourth, I gave you credit. But if you called it quartic, I gave bonus point. So on the quiz that you'll have later on over this kind of stuff.
So I don't really have to memorize like 14.
Well, if you read it, you need to know what it is. But if you actually wrote it on the quiz, instead of just saying like fourth, and you wrote quartic, I gave a bonus point. It's an easy bonus point.
I'm just gonna memorize like.
No. All right, what order should this one be written in? Good. By its degree, you would call it quartic. Quartic. And what do you call it? Trinomial. It's got 3 terms. All right, and that last one, what order should that be written in? That's not problem number 3. That's the 4th one on the page. I laugh because every year somebody does that. They're like, it's in the right order. No, it's not. That's not problem 3. I love messing with you guys. It's fun. Yeah, this is not problem 3. This and this is like terms. This is the 4th one on the page, too. That's why I love that. People are like, what? That's number 3. No, it's not. Yeah, so people start on the back page and don't do the front page. There's a front on this?
That was kind of funny. Like you had to start like problem 11.
Yeah, he did.
Most teachers don't put them in the right order.
I put things in order. Bothers me. Yeah. Oh, even if I do that, I go back and renumber them because it bothers me. Yeah, I do. Now you know. Now you know, though, right? All right, anyway, by its degree. Thank you, quintic. And by its terms, trinomial. Cool. How we feeling? Good? We all right with that stuff? Makes sense? You could at least reference your notes at this point and figure it out? Okay. Oh, yeah. All right. The next thing we need to talk about are what the graphs of these things look like. I told you in this section, I'm not asking you to graph and stuff in this section, so don't be panicked that I'm going to ask you to do a lot of that. But the graphing calculator becomes your best friend as we get going through and solving these. It's already your best friend. So these graphs, they'll be continuous. There'll be no breaks, no gaps, no holes. They'll be just nice, smooth, curving lines, whatever. So no sharp turns. This is an absolute value graph. They look like V's. So you won't have sharp points. So if I ever ask you to draw them, please don't put sharp points on them. Still right? Oh, okay. So I want you guys. All right. So let's go ahead and talk about it. What did x squared look like? You guys should know the actual name for it. What's it called? The graph of x squared. Parabola. Thank you. Chapter 4 was all quadratics and they graphed as parabola. Thank you, Angry Bird Project. Don't file that away for like never remembering because all of it comes back in chapter 5. All of it. As in, like, don't forget, I'm being very serious. Do not forget quadratic formula, factoring, square root method. Square root method you could probably file away until exams, but the rest of it, I mean, it's all coming back. All right, what about negative x squared? What did the negative do to it? I just flipped it over. Flipped it. So between the negative x to the third, what did this one look like? The opposite. Squiggly up versus squiggly down. That's very technical terms there. You got that? What about x to the fourth? Look like x squared? It looks a little different, right? A little bit. And honestly, these could look way different. What we are talking about with why I'm having you graph these and look at these, we're talking about its end behavior. Meaning the ends. Are they pointing up? Are they pointing down? One up, one down? Which way are they going? That's what we're talking about. Because all the stuff in between these ends could change. Okay? Like you could have an extra little curve in there where it looks more like a W. Or looks more like an M for that one. It just depends what else is with it. Like if it's x to the fourth plus 3x cubed minus 2x, you know, I mean, like there's other stuff, it changes the way that graph looks. So same thing, x to the fifth, what did that one look like? Squiggly up. This one looked like squiggly down. X to the sixth, happy face. And negative x to the sixth, sad face. He's sad. Okay. So odds were called, what did we call them? Squigglies. Squiggly up or squiggly down? How did you know if it was squiggly down? The negative out in front, right? Okay. From left, we read from left to right. Okay. All right. Yeah, from left to right, it's going up. All right. What about evens? What do they look like? Happy face, sad face. How'd you know if it was happy? It was positive. How'd you know if it was sad? It was negative. Good. That's the whole next part. All right. So what you guys just summarized, we're going to summarize in this table because you have to know this. Without looking at the table, you will have to know this. So we're talking about its end behavior. Again, if it's going to be pointing up, pointing down, that kind of stuff. That's what we need to be able to recognize. So if the exponent was even and the coefficient or the number in front was positive, what did it look like? It was a happy face. Yay. And if it was even but negative, it was a sad face. So again, it's ways to kind of remember this stuff because you're going to have to memorize it. I always think about, have you ever heard somebody called like an even-keeled person? Like you guys have never heard that term? All right, that didn't work. All right. So smiley face, sad face. Yay? We know what those are. But what if you're kind of odd? You just got a squiggly? If you're odd and positive? You're very upbeat. You got a squiggly up? Your smile looks a little odd, doesn't it? And if you're kind of odd but negative? Squiggly going down. All right. You need to memorize that. Okay? All right. So you have that to reference. Let's kind of put it into practice. Good. I'm glad that you don't think it's bad. So take a look at the first problem up there. The directions, I want to make sure you're aware of the directions. Describe the right and left-hand behavior of each graph. What it's looking for is, I'm okay if you draw me a picture. That's what I like to do. It's easier to just draw a picture. You're telling me what the graphs, at least the ends of it, are going to look like. Are they up? Are they down? One up, one down? What's it look like? You can write left, up, right, down, whatever if you want to. It's easier for me, I just draw the picture. Okay, so on the first one, 3x cubed minus 9x plus 1. So your exponent, even or odd? Is odd. Number in front is positive. Yeah, don't confuse. We're talking exponent, even or odd. Exponent starts with an E, even starts with an E, exponent, even or odd. And this is a squiggly up. Right? Because it's positive, and he's kind of odd, but he's positive. What's wrong? So was one end, the first end going down and the other end pointing up? Right. Again, what happens in between there can change. We're talking about the ends of it. That's fine. As long as the one end's pointing down and the other end's pointing up, I don't care. But you had a very valid point. Am I letting you use a graphing calculator? All right. X to the fourth minus 2x cubed. Without graphing for a second, Cole. Make sure you can do it without graphing. I don't care if you look at it, though, in the graph. But exponent, even or odd? Positive or negative? Smiley or sad? Use smiley face. All right, Cole, graph it in your calculator. Again, so what happens in between the ends? Can it vary a little bit? Yeah. What happens in between there can change. All right, take a look at the next one. X to the third minus 3x plus 2. What's this negative and 1/3 going on out here? It would need to be distributed, negative 1/3. Do I really need to do the math of it, though? No. Exponent, even or odd? Odd. So I know it's a squiggly one. Is it squiggly up or squiggly down? Down, because you're going to have to distribute the negative 1/3 to it. So this one's going to be a squiggly down. And again, if you look at the graphs, you can see some different stuff goes on in between there. But the ends, it's very technical. And the last one, even or odd? Positive or negative? So what's that mean? Sad face. All right, let's try just a couple more, make sure we got this idea. So number one, exponent, even or odd? And positive or negative? So what's that mean? He's going to be happy. Good. Number two, exponent, even or odd? Odd. Positive or negative? What's that mean? Squiggly down. Number three, exponent, even or odd? Odd. Positive or negative? What's that mean? Squiggly up. Number four, even or odd exponent? Happy or sad? It's negative, so he's sad. All right, how are we feeling about all that stuff? You're good? You're good. Nope. The last thing we need to talk about is just what you guys were kind of looking at on your calculator. Sometimes they have like another little curved part. How many little curves could they have?
4.
Well, that's what we need to talk about. Okay? So if a polynomial has a degree of n, so x to the fifth, per se, we'll just say that, then the graph has at most, that's an important word right there, at most, n minus 1 turning points, or changes in direction. So, for instance, if I have an x to the fifth, 5 minus 1 is 4, so this should have at most 4 turning points. So if I look at this graph, 1, 2, 3, 4. Since there are 4 like places where it changed, like going up to down, right, where it's changing direction, that's a fifth degree. Right. So this end behavior, is this a positive or a negative x to the fifth? It's negative. That's a squiggly down. So this would actually be negative x to the fifth. The reason it says at most is we graphed negative x to the fifth, didn't we, on that paper? Did your negative x to the fifth have 4 turning points on it? No. It could have 4 turning points or less. Right. It would have to have at least 1. Okay. Does that make sense, though? It could have 4 or less. We recognize that. All right. So the other way, though, I want to make sure we're clear on is, can we think of that backwards? This is talking about the degree minus 1 is how many turning points. What if I give you the turning points? How do I find the degree? You would add 1. So make sure we're cool with that, too. Turning points plus 1 equals degree. This is not hard, but people forget that they write this down, and then they're like, I don't know how to do this. You can count, can't you? You can add 1, can't you? Because a lot of times, like on a quiz or something, I'll give you a picture of a graph, and I'll ask you, what degree is this? Well, count how many turning points you have, and then you can add 1. You can tell me what the degree is. So let's go back real quick and take a look. So number 1, this was x to the 4th. So at most, how many turning points? It would have 3 turning points. Right? Because you would do 4 minus 1 is 3. It has 3 turning points. Number 2, x to the 5th has how many turning points? 4. Does it have to have 4? At most, it would have is 4. All right, this one, x to the 3rd, would have how many turning points? 2 turning points. X squared has how many turning points? 1. Can I have less than 1? No. It's going to have at least, it will have 1. All right, so real quick, let me kind of talk to you again about it the opposite way. Let's say I have a graph. That. How'd she get x to the 7th? 1, 2, 3, 4, 5, 6, plus 1. It is a 7th degree. Is this going to be squiggly up or squiggly down? That's squiggly up, so that means this is positive. That's positive. What's that? She's on this. Turning points, 1, 2, 3. Turning points plus 1 is the degree. So this is going to be x to the 4th. Is it positive or negative? Negative. See how it's frowny faced, pointing down. This is actually a negative x to the 4th. Yep. This, x to the 5th. At most, that's how many turning points. But it could have less. It could be something else. But at the minimum, it's going to be at least x to the 7th or x to the 5th, or whichever one. Because it could have more.
It can have at most, like that one have at most 4, but
Mhm.
it has to at least have 1.
Right. It'll have at least 1. So it'll be anywhere between 1 and 4 turning points. And you're right. When I'm looking at the graph, all I can do is a best guess. It could be something. It could be x to the 50th for all I know. So our best guess is it has to at least be x to the 5th. Because there's 4 turning points. So it's at least x to the 5th, probably. It's not going to be x to the 4th, because x to the 4th doesn't have that many turning points. Yeah, it's our best guess. We don't know for sure.